Hey, what's up? It's Joe Reis. I'm here to talk to you today about why metadata is key to cross-disciplinary data modeling. So, what you'll learn. What is data modeling? Why is data modeling important for AI? And why metadata is key for a cross-disciplinary data modeling. I'll get into what that is as well. I think the first question you need to ask yourself is, what is data modeling? Right, I ask this question around the world and get a variety of different answers. I have my own definition, which I'll show you in a bit. But I think it's important to start off from first principles. But I think all too often data modeling is perhaps a bit misunderstood. Especially in the context of today's way that we work with data. So what do you think data modeling is? Do you think it's a particular technique or an approach? Maybe you're talking about the relational data model. Maybe you're talking about dimensional data modeling or data vault or one big table. These are all analytical data modeling approaches. Maybe you think that data modeling only applies to databases. I mean, it's a fair thing to think, since most data modeling is taught in the context of databases. But is this really what data modeling is? And if so, how does it fit into the broader context of how we're working with data today? Is it only a particular technique or approach? Is it only about databases? My definition, this is what I'm using as the definition in my new book that's coming out on data modeling. It should be out early next year. But I define a data model as something that organizes and standardizes data in a precise structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate actions. So again, a data model organizes and standardizes data in a precise structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate actions. And notice what this definition covers, right? It's agnostic to any particular data modeling approach. It encompasses all use cases of data. It includes machine learning and AI, which will increasingly appear in more and more apps, as well as analytics. You can already see this happening with the number of vendors out there introducing some sort of either copilot or AI workflow into even traditional modern data stack tooling. This definition also covers humans and machines. I believe increasingly humans will be working alongside machines in an ever-increasing fashion. AI is going to augment a lot of what we do as data practitioners. And so it's incumbent upon us to understand, the data that machines are using. And I could make an argument this is always how it has been. If you look back to even when we had modeled data for databases and relational databases, these are mostly for applications, which is automation of tasks with code and data. And so really the only time we've actually consumed data as human beings is when we're doing analytics, right? You look at tables of data, you might look at visualizations of data, but at the end of the day, you're really consuming data for knowledge and understanding and wisdom and so forth. And but increasingly, we're moving into an age where machines, namely machine learning and AI, will be using more and more data. So that's what this talk is about. How do we make data useful for humans and machines? And I think data modeling is core to this. So why is data modeling important for AI? Let's look at a few examples from the current zeitgeist, right? I think some current trends we're seeing right now is AI is everywhere. It doesn't take a lot of effort to find AI in a lot of tools these days, tools that were traditionally just traditional SaaS or even on-premises applications and so forth. Data lakehouses seems to be the gravitational pull of data is more towards the lakehouse architecture. I think we're just getting started with both of these phenomena, really. Although AI has been around for many, many, many decades, the current zeitgeist, the current trend of it really is, for the first time, you've really seen the consumerization of AI. I think it started with ChatGPT, and now obviously if you use a smartphone. Machine learning and AI has been in that workload for a long time. But you couple this with the rise of the data lakehouse, really, where increasingly data will be sort of a decentralized, neutral location, and various use cases will be available for that data, right? Whether that's machine learning, whether that's throwing whatever query engine you want to it. So the world's opening up to a lot more possibilities of data than we had even back in the modern data stack era. So, this is the classic lake house picture. It's very serene, very beautiful. I think this is what we all aspire to with our data. And, it's a great aspiration, right? I think the notion of the lake house is a very peaceful place to put all sorts of data that we can use for, analytical use cases, machine learning, even data that goes back into applications, right? This feedback loop will continue to tighten. But what's really lacking is obviously, I think, a sense of rigor around how we treat data. I think all too often, this lake house, though it's a great ideal, it turns into something a bit different, right? And at the same time, there's a lot of promises about AI. AI is going to transform the business. It's going to unleash enormous productivity for people, employees. And AI agents will run, my company's operations and so forth. These are the promises being made for AI. But you couple this with the serenity of the lake house, and what you get really is more like the data trailer park, where it's a bit humble, it's a bit dirty, and I think this is the data stacks that most companies tend to devolve into. Again, if you hold this as your ideal, this is great. This might represent a few companies, but overall, this is the reality of a lot of data stacks today, and it's a bit sad, but this is the reality of it. And is this what we are going to accept as an industry, as practitioners? I certainly hope not. Right? I think we can do better than this. And the reality is that most data sets, they're a disaster, right? We're still struggling to do analytics on top of most data sets. That's just the reality of it. Some companies succeed, most are still struggling along. The amount of tech, data, and organizational debt that results is incredibly high and continues to grow. It's very hard to integrate data together, right? You try and find different data sets from different domains, businesses, business processes, whatever, and integrate them. It's really hard to do, right? But increasingly, we're dealing with a world that's not just structured data anymore, rows and columns, right? Even semi-structured. We're dealing with images, text, video, audio, metadata, graphs. All these different types of data are now melding together, right? I was just actually talking to a colleague the other day who's using large language models to bring in a bunch of text data, and by the use of metadata, integrate that with the data that they have in their transactional databases, right? We're talking millions of text records that, to this point, were not usable by the business. Nobody had any use case for them from a technical angle. But now, with large language models, this person was able to get a lot of value out of these data sets. And finally, the reality is, if we're not going to take things like data modeling, data cataloging, metadata seriously, we're trying to get our data house in order here, then when are we going to do it, right? The attention's on AI, the attention's on data, the budgets, the willpower's here right now. This is the time to capitalize on it if we're ever going to do it. I've never seen a time in the industry where there's been such an opportunity as there is today to get our data house in order. But to me, it starts with things like data modeling, great metadata as a result of a great data model, and integrating data in a way that it's useful for analytics, AI applications, and so forth. And data modeling is obviously key to this, right? I think this is one of the root causes. The lack of data modeling is one of the root causes of some of the problems we have, right? But some attributes of good data modeling is it improves data quality. Obviously, it means you can integrate data sets together because you have proper referential integrity between data within maybe one form, maybe it's structured data, but also across different forms of data, whether that's images, text, video, et cetera, right? So data modeling is sort of how you think about the data and translate it into some physical manifestation. But now we're not just dealing with one form of manifestation like we used to back in the day of databases. We're now dealing with many different types of data. But how do we integrate all this together? To me, this is about data modeling. It's about taking the higher level concepts in the business and translating those down to the different types of data, the different use cases we have. Turns out data modeling is cool again. As I've been traveling the world giving talks on data modeling, these have been widely attended all over the world. Lots of great questions, lots of enthusiasm. So I'm excited to see data modeling becoming a topic of of discussion nowadays, and a legitimate one too. For a long time, it felt like data modeling was very uncool. People kind of forgot about it, thought it was a lost art, but it's back. It's back with a vengeance, and it's key to making everything work. This is literally our job, is to model the concepts, the business rules, the vocabulary, the information flows of the business into great models. If you have a great model, your data quality is awesome. Everything just works. If you have crappy data models, you get that data trailer park I mentioned earlier. And that's the sad reality, is we don't think about the data. We don't model it the way it should be modeled, and we get what we get. But we're doing better. We're doing a lot better. And again, if we're not going to do it now with all the attention on data, on AI, all the money, all the willpower to do this, and when are we going to do it? When are we going to do it? So let's talk about cross-disciplinary data modeling. What is it? Well, it's something I've been calling mixed model arts, sort of a play on a mixed martial arts. But the notion is, instead of focusing on one particular use case, one particular style, right, which is sort of the world of maybe pre-mixed martial arts, what we're dealing with increasingly are multimodal data sets, different forms of data, unstructured, semi-structured, structured data, all blending together, right? Underpinning all this is metadata, of course. And then obviously data modeling across various use cases, applications, web, mobile, integrating that in analytics integrated into applications, machine learning, AI, right? All these things feed internal use cases, external use cases, facing customers. And what you're seeing is a convergence of, again, different forms of data you're working with, different use cases. And increasingly, the lines are going to be blurred, right? You're dealing with batch data, streaming data, like I said, apps, analytics, machine learning, and again, different types of data. But again, this is the essence of cross-disciplinary data modeling, or what I call mixed model arts. So what we've been, right? I think up to this point, we've focused mainly on structured data, right? So the data catalogs, the data quality, the lineage, the schema evolution, and version control. It's been focused on things that fit into tables, namely rows and columns, right? Lots of great metadata that you can use for this. Lots of great use cases. To me, this is a solved problem to a large extent. There's still a lot of work, obviously, to work on the details, but it's some of the issues I have right now is I don't think that there's any shortage of great tools. I think a lot of it comes down to good practices like data modeling, which have been largely forgotten, right? But we have the tools, I think, to make great wins with structured data right now. But this has been the focus, right? We're talking applications, I kind of lump semi-structured data like JSON and so forth into this. But we've gotten a lot of good wins so far. Is there a long way to go? Absolutely. But for the most part, with all the attention that's been on structured data for decades, the tools are in place to do this. Data modeling is one of the components where I feel like that's more of a practice. It's not a technology discussion. And so hopefully, with the practices of data modeling coming back into vogue, structured data modeling is, you start seeing some big wins on this. And obviously, in the modern data stack world, the big focus has been on analytics, right? But increasingly, the world's moving beyond traditional structured data. Where we're going, practitioners need to know how to model and work with unstructured data, text, images, audio, video, metadata, lumped in there, graphs, and so forth. Actually, graphs are more structured, but you get the idea. Non-structured data sets. A lot more machine learning and AI. This is a big one. I can't tell you how many software engineers, how many analysts I talked to who, even a couple of years ago, had no interest, no desire to learn about machine learning and AI. That's not the case now. Everybody's jumping into machine learning and AI. Why? Because they know it's going to be just an integral part of their own workflow. They're going to be implementing models into what were traditionally data workflows and so forth, right? So that's just the reality of it. You're going to start seeing a lot more metadata being integrated between structured and unstructured data. Again, the metadata up to now has been mainly focused on structured data, but increasingly you're going to start seeing the integration of different forms of data, structured and unstructured. The metadata is going to be very useful to make explainable data models. This is going to be very key when we're talking about models that provide ethical, hopefully unbiased results, right? As well as certain industries where you just need explainability and interpretability. So as much as possible, metadata is key to making this work. Metadata is also key for the data lineage of these AI models, right? And finally, metadata, learning to work with unstructured data. This is all key to data-centric AI. This was a notion that Andrew Ng came up with back in 2021. But it's a notion that without great quality data, it won't really matter how sophisticated algorithms are, how much hardware you throw at the problem. If you don't have great quality data, you're not going to get the best models that you can. And so all this ties together, right? But it comes back down to properly modeling your data, which provides better metadata for your structured, unstructured data, your machine learning models, and everything else. So closing out, I feel that we're definitely at the golden age of data right now, and we're only beginning things, but we need to take things like data modeling very seriously. We need to have great metadata, rich metadata, not just in structured data sets, but across various forms of data, various use cases. Again, the world is moving towards an integration of apps, analytics, machine learning, and AI across different types of data. And if you're watching this conference, if you're a part of it, it's incumbent upon you to learn the various techniques and approaches to working with data. And it's only by doing this that we can make things like data-centric AI, great data sets, a reality. And I think we can do it. Thank you.